Good morning, sir. I am Y. Nikita from EC Department B section. My Tech Talk topic for physics is Quantum Photonic Network Concept, Basic Tools, and Issues. Introduction. Pursuing high capacity in optical communications, one has recently reached the quantum limited regime where the signals are densely packed in the phase space so that quantum indistinguishably of the signal states becomes a matter. Further improvement to increase the ratio in bits or seconds or hertz or photon requires quantum engineering. The fact disclosed recently that fibers were actually tapped over a long time by intelligence agencies these decades have convinced one that physical layer security is an urgent concern. This emerging platform is to integrate QKD for highest security, quantum communication for power minimum, maximum capacity, communications, and a new scheme of physical layer cryptography which merges the merits of these two to realize the secrecy capacity with the provable security into a network. Increasing the capacity and ensuring the security are generally competing tasks. In a new network paradigm, various QKD schemes, physical layer cryptography, algorithmic cryptography, and optical or quantum communications are integrated in an interoperable manner, depending on user needs and allowed costs. Quantum Photonic Network. Photonic network is an emerging infrastructure of optical communications. It is to utilize the broadband of optical fields and to resolve the speed limit and heating of electric devices. Networking and routing are carried out by all optical processing and with wavelength switching which is performed by the optical cross connects OXCs. Networking and extending the range of QKD must rely on the key relay via the trusted nodes at present. Security of the nodes should be protected classically. The QKD network can solve this problem if the keys and their identifications can be properly managed in the trusted nodes. The QKD platform will be introduced to the photonic network to enhance its security at each layer. It is a never ending task in any practical security technologies to find security loopholes and side channels and to implement countermeasures. QKD itself is not an exception. Actually, several side channels of QKD components have been identified and their countermeasures have been developed. Photonic network is in a wider usability side, realizing broadband and long distance transmission. Its security is based on algorithmic cryptography. which is implemented in layer 3 or the upper layers. QKD and related technologies. A. Based on Heisenberg's uncertainty principle. BB84 and variants. A single photon pulse is passed through a polarizer. Alice can use a particular polarizer to polarize a single photon pulse and encode binary value bits to the outcome of a particular type: vertical, horizontal, circular, etc. of a polarizer. On receiving the photon beam, Bob would guess the polarizer, and Bob can thus match the cases with Alice and know the correctness of his guesses. Thus, in such a system, if Eve tries to eavesdrop, it will get to the notice of Alice and Bob. BB84 has a similar protocol, SSP, that uses 6 states to encode the bits. SARG is another protocol that uses attenuated lasers and provides better results than BB84 in more than one photon system. B. Based on quantum entanglement, E91 and variants. There is a single source that emits a pair of entangled photons with Alice and Bob receiving each particle. The outcome of the results of the match cases of Alice and Bob will be the opposite as a consequence of entanglement principle. Either of them will have complement bits in bit strings interpreted. One of them can then invert bits to agree upon a key. Since Bell's inequality should not hold for entangled particles, thus this test can confirm the absence of eavesdroppers. Since practically it is not possible to have a third photon in entanglement with energy levels sufficient for non-detectability, thus this system is fully secure. Possible attacks in quantum cryptography. Photon number splitting attack, PNS attack. Some of the photons from a pulse can be captured by Eve, and after matching of bits by Alice and Bob, Eve can use the same polarizer as done by Bob and thus get the key without being detected. Fake state attack. Eve uses a replica of Bob's photon detector and thus captures the photons intended for Bob and further passes it to Bob. Though Eve knows about the encoded bit, Bob thinks that he received it from Alice. In quantum photonics, we are study quantum and coherent properties of light and its applications. In this area, the research group is focusing on developing techniques to control the quantum dynamic of a single quantum light which interacts with a single quantum of matter. Basic principle. There are various principles referring to application we will discuss later, but the most required property which is used is quantum state of the photon and its coherence. Photon has two polarized states which may be horizontally represented by H. A qubit, a quantum bit of information, can be encoded using the horizontal H and vertical H polarization of a single photon. And magic is that it can be both states at same time, which we called superposed state before measurement. Also, property of quantum entanglement of photons are used in some applications. Here, we provide a broad review of photonics for quantum technologies touching on the topics including secure communication with photons, quantum information processing, quantum lithography, and quantum integrated quantum photonics. Advantages of quantum photonic network. Transmission at the speed of light and low noise properties make photons extremely valuable for quantum communication, transferring of quantum state from one place to another. It's allow more secure transfer of information and perform accurate measurements. Quantum technologies will be able to implement faster algorithms, or we can say fast computing. A reasonable approach is to deal with multiple possible realizations for the wiretap channel, each of which is actually occur is known. The number of secure bits delivered to Bob depends on the actual realization of the wiretap channel. Eventually, the known schemes of QKD and prospective schemes of physical layer cryptography will be integrated on photonic network infrastructures to realize high capacity communications with the provable security. Future challenges: quantum computer, multi particle teleportation, quantum communications, quantum meteorologic strategies, optical quantum memory, quantum and rest. Conclusion: our QKD systems are deployed into practical metropolitan scale networks and are integrated into the QKD platform for a new solution for key exchange and key supply. Entanglement QKD can be put into shorter distances links such as important intra networks. In order to realize secure global network with the provable Security. One must rely on physical layer cryptography while assuming that the wiretap channel to Eve is physically bounded. We have developed a theory to quantify the trade off between the reliability and the secrecy in finite code length number n under the cost constraint. In optical space communications, which are basically line of sight links, the degraded wiretap channel condition seems reasonable in practice. It indicates a direction to unify optical or quantum communications with coding and cryptographic technologies, which is indeed an endeavor in information and communication technologies. A reasonable approach is to deal with multiple possible realizations for the wiretap channel, each of which actually occur is unknown. The number of secure bits delivered to Bob depends on the actual realization of the wiretap channel. Eventually, the known schemes of QKD and prospective schemes of physical layer cryptography will be integrated on photonic network infrastructures to realize high capacity communications with the provable security. Our QKD systems are deployed into practical metropolitan scale networks and are integrated into the QKD platform for a new solution for key exchange and key supply. Entanglement QKD can be put into shorter distance links such as important intranetworks. In order to realize secure global network with the provable security, one must realize on physical layer cryptography while assuming that the wiretap channel to Eve is physically bounded. We have developed a theory to quantify the trade-off between the reliability and the secrecy in finite code, length n under the cost constraint. In optical space communications, which are basically line of sight links, the degraded wiretap channel condition seems reasonable in practice. It indicates a direction to unify optical or quantum communications with coding and cryptographic technologies, which is indeed an endeavor in information and communications technologies. Thank you, sir, for giving me this wonderful opportunity of sharing my knowledge on a tech talk topic, quantum photonic network. Thank you, sir.